Today we're going to learn about the unit circle, specifically sine, cosine, and tangent on the unit circle. When you're finding sine, cosine, and tangent on the unit circle, you're going to have to use a concept that was taught in geometry, and it was called special right triangles. Special right triangles includes 30, 60, 90, and 45, 45, 90 triangles. If you don't remember these, there is a review sheet posted on my website that you can take a look at, and it goes through the formulas and how you're supposed to do it. To start this note sheet, we need to go over some problems that we learned last week. So writing in radians and degrees, and also sketching an angle on the coordinate plane. Please follow along as I complete these examples. Here we have the unit circle. So the unit circle is a very common topic in trig. It's actually the main topic, so something that we're not spending too much time on this year, but we'll spend a lot of time on next year. And the unit circle is a circle that has a radius of 1. So you're going to hear me throughout the note sheet refer to an R value of 1. That's the radius. So anywhere on the unit circle, the radius is 1. Here is an example of the radius. So from the center of the circle to a point on the unit circle, the radius is 1 unit. Any right triangle formed by the radius has a hypotenuse of 1. So that's another way you can look at that. If I zoom in on this orange line I just traced, and I drop a line right back down to the positive x-axis, this just formed a right triangle. The radius is 1, but we could also call the hypotenuse of the triangle 1. Before we start doing examples, I'm going to go over quadrantal angles, so we'll talk more about this in just a moment, but I want to point out a few things. There are some benchmark points, I could call them, because they're easy ones on the unit circle, and it's where the x-axis or positive x-axis intersects the unit circle, which is here. That specifically has a point at 1, 0. At 90 degrees where it intersects the unit circle, we have a point at 0, 1. 180 is at -1, 0. 270 is at 0, -1. So those are going to be some key values, but also easy values to remember when you're working on the unit circle. All right, your sine, cosine, and tangent values when you are on the unit circle. They are determined by your ordered pair. So if we have a point on the unit circle, I know this is labeled point P, I'm going to relabel it point P at x comma y. All right, your sine value is always your y value. So whatever your y value is will be your sine value. Your x value is going to be your cosine value. And your tangent value is when you have sine over cosine or y over x. And those are the three values that we'll be learning this year. There are more than these three, but this is all we're learning now. Today we're going to continue solving trig functions. We're going to start off by learning about quadrantal angles, and quadrantal angles are always using the unit circle. Quick reminder from the previous lesson, if you're using the unit circle, that means that the radius is 1. Anytime you see the unit circle, you have to assume that. So when the terminal side of an angle that is in standard position lies on one of the coordinate axes, the angle is called the quadrantal angle. A quadrantal angle is one that is in standard position and has a measure that is a multiple of 90 or pi over 2 radians. So if we look at my table here, I have 4 different quadrantal angles. And these angles are all given to you in positive values. However, remember that you can have negative angles. They do exist and they will correspond with these values that I gave you. They will just work in the opposite direction. So my note right there just says that these are all positive. Negatives exist and they will correspond with these angles. If we start in the box all the way to the left, we're looking at 0 degrees. 0 degrees is also 360 degrees if you were to make one full rotation around the coordinate plane. And 0 degrees is 0 radians. However, if you were to use 360 degrees, 360 degrees is 2 pi radians. If you were to reference the negative angle, like I mentioned, you would have 0 degrees, or you would have 360 degrees. Oh, I meant to say negative on both those. Negative 0 degrees, negative 360 degrees, or you would have negative 0 pi or negative 2 pi. So those are your options for negative values in this angle location. So we're talking about the angle being right there. If you have a angle in standard position graphed on the initial side and the terminal side is at 90 degrees, this would be a 90-degree quadrantal angle. This happens at the point 0, 1. Remember that the radius is 1, so when we say 0, 1, that's telling you the length of this side is 1. 90 degrees is comparable to pi over 2 radians. And if you were to graph this angle in the negative direction, say you were to graph this angle going in this way, you would say that it's either negative 270 degrees or negative 3 pi over 2 in radians. That's if you work in the negative direction. For the next point, we're looking at initial side at 0, terminal side at 180 degrees. 180 degrees is comparable to pi radians. This point is located at negative 1, 0, and that's because the length of this part here is 1 unit. Of course, 1 unit in the negative direction on the y-axis. Sorry, the x-axis is at -1. If you were to graph the same angle in the negative direction, in this case you would be at -180 or -pi. And lastly, if you graph initial side at the positive x-axis, terminal side on the negative y-axis, you're looking at a 270-degree angle with a point, a point located at 0, -1. This is comparable to 3 pi over 2 radians. And if we were to write this as a negative, so meaning if we start here and go to this point, we're at -90 degrees or -pi over 2. So you can find the values of the trig functions of a quadrantal angle by choosing a point on the terminal side of the angle and evaluating the function at that point. Any point can be chosen. However, to simplify calculations, pick a point which r equals 1, and that's the points I highlighted on these. So I'm talking about this point. I know I didn't mention it much before, but we're talking about this point. So if you choose that point, then the r value is 1. It's the point where your angle intersects what we call the unit circle. But now we're going to start using our 30, 60, 90, and 45, 45, 90 triangles. So again, if you are feeling like you're missing some info on these, go back to that warm-up sheet that I started talking about. There's a lot more notes on these triangles on that warm-up if you're interested. Before I start, I need to talk about the quadrants. So we have quadrant 1, and in quadrant 1, your x-coordinate and your y-coordinate are positive. In quadrant 2, you have a negative x-coordinate and a positive y-coordinate. In quadrant 3, you have a negative x and a negative y coordinate. And in quadrant 4, you have a positive x and a negative y coordinate. So you need to make sure the signs correspond to the quadrant. Your answers are always going to come out positive, but you have to determine where the point is that you're working with and match it to the correct quadrant. Make sure you have the correct signs. You'll see when I go through the example what I'm talking about there, but this is important to know. Looking at the first example, we're trying to find the cosine and sine values. That's all we're looking for here, cosine and sine values of each angle. We're going to start with the angle 60. So I'm going to draw this angle 60 on my coordinate plane, which, by the way, this is just the unit circle. I already have it drawn in for you. So I have my initial side. My terminal side is located at 60 degrees. Okay, so if that's located at 60 degrees, we know that the radius is 1. We know this length here is equal to 1, but we don't know anything else in order to find the x and y value. So when I say x and y value, I'm talking about this point that intersects at the unit circle. We're looking for x and y, but we don't have any other info to do that. So what I'm going to do is I'm going to drop a line down to the x-axis, a perpendicular line to the x-axis, so forming a right angle, and also forming a 30-degree, 60-degree, and 90-degree angle. So this here is a 30, 60, 90 triangle. And just to refresh your memory on the formulas that we're going to be using, in a 30, 60, 90 triangle, the hypotenuse is equal to 2 times the short leg, and the longer leg is equal to the short leg times the square root of 3. So we're going to use the triangle. We're going to use this triangle, and we're going to find our value of x and y, which is going to be our sine and cosine value. I'm going to redraw this triangle just so we can clearly see it. I'm also going to label the sides for you. So the hypotenuse is always the diagonal. The short side is literally the short side of the triangle, but it's also always across from the smaller angle. And then the long side is your last leg. So if we know the length of the hypotenuse, then we're going to start with that. Okay, you start with whatever you know. We know the hypotenuse, we're starting with the hypotenuse. Knowing that the hypotenuse is 1, we can substitute 1 in for that value, and we have 2 times the short leg. I'm going to label the short leg x because up here, the short leg is on the x-axis. So 2 times x. In order to solve for x, I divide both sides by 2, and x is equal to 1/2. Here's your x value. I'm going to label the long leg y because this leg right here runs parallel with the y-axis. If I know that x is equal to 1/2, or I know that the short side is equal to 1/2, I'm going to substitute in my value of x for the short side. Long leg is y, which is equal to my short side, which I just solved and is equal to 1/2, and then the formula says multiplied by the square root of 3. So this ends up simplifying to y equals the square root of 3 over 2. And there's your y value. So no matter what the problem is that you're working on, your x and y value are always going to end up being positive numbers like they are here. But then you have to identify where your point is. And okay, this point right here is in quadrant 1. Quadrant 1 indicates that both your x and y values are positive, so that's it. We don't need to change our signs. But sometimes you will have to, like the second example I'm going to go over. Also, once we find these points, once we know that x is 1/2, and once we know that y is square root of 3 over 2, I can rewrite this ordered pair, and I can write that as the point 1/2, comma, square root of 3 over 2. All right, my x value is how far we went over on the x-axis. My y value is how far we went up on the y-axis, and those two values correspond to your x and y, or your short and long legs. So now that we have this info, we're looking to find cosine of theta, which recall cosine is x over r, or x over 1 because r is 1, which is just your x value. So your cosine is your x value of 1/2. And sine of theta is y over r, or y over 1 for the radius. Simplify that to just your value of y, which in this example is the square root of 3 over 2. There's your sine and cosine value. As for the tangent value, recall that tangent is always going to be your y value over your x value, or I could say your sine value over your cosine value. So to fill in the tangent value, I'm going to write my y value or sine value, square root of 3 over 2, divided by my cosine value of 1/2. Remember, when you're dividing fractions, you are doing the same, or you can multiply by the reciprocal to give you the same answer. So instead of dividing square root of 3 over 2 by 1/2, we are going to do square root of 3 over 2 times 2 over 1. I flipped the second fraction. I am multiplying by the reciprocal. Here I can eliminate my value of 2, and for my numerator I'm left with just the square root of 3, and for the denominator, I'm left with 1. So square root of 3 over 1, or just the square root of 3. And that's your final answer for number 1. Okay, next we're going to look at the angle of 225 degrees. So same thing, we're looking to find our sine and cosine value of 225. So I'm going to start by sketching the coordinate plane, and I'm going to sketch 225 degrees, which lies 45 degrees past 180. I'm also just going to sketch the unit circle. And I'm going to mark where my point intersects the unit circle. So this is the point where we're looking for x comma y. All right, I don't know anything besides from the fact that the length of the radius is 1. So the 45-degree reference angle indicates I can draw a line back to the positive x-axis, and right there I just formed a 45, 45, 90 triangle. If I resketch it a little bit larger, we have our 45-degree reference angle, we have our 90-degree angle that we formed, and remember the interior angles of a triangle add up to 180, so what's left over is 45 degrees. Now in a 45, 45, 90 triangle, it's important to know that your legs are congruent, meaning they are equal. So it doesn't matter which one you label because they are both called the leg. This is called the hypotenuse, and the length of the hypotenuse is the only length we know, which is 1. I'm gonna, just for the sake of explaining, label that part or this part of the triangle as x because it lies on the x-axis. And I'm gonna label this part of the triangle y because that represents the distance traveling down on the y-axis. And now I can use my 45, 45, 90 triangles to solve for the missing side lengths, and which will add to or allow me to solve for the missing values of x and y. There's only one formula for the 45, 45, 90 because the hypotenuse is one length and then the legs are both the exact same length. So the only formula you need to know is a leg length times the square root of 2. Well, we already know the hypotenuse length, so that's where we're going to start. We're going to substitute 1 in for the hypotenuse, and this is equal to, we'll just use x, but you could use x or y, x times the square root of 2. If you solve for x, you're dividing both sides by the square root of 2. And just remember right here that you cannot have a square root in the denominator, so I need to multiply the numerator and the denominator by the square root of 2, giving me the square root of 2 over the square root of 4, which is 2. And that's equal to x. So recall that x and y are congruent, they are equal to each other. So if the square root of 2 over 2 is equal to x, then the square root of 2 over 2 is also equal to y. Now, before I can write my ordered pair, this point is in quadrant 3. If it's in quadrant 3, that means you have a negative x and a negative y coordinate. Your answers are always going to come out positive, but you have to make sure you apply the correct signs. So when I write this point, I need to write this point as my x coordinate of square root of 2 over 2, but that is now negative, and negative square root of 2 over 2 for my y coordinate. Recall that cosine of theta is x over r, or x over 1. In this case, the x value is the square root of 2 over 2. And sine of theta is equal to y over r, or y over 1, which is just y. So the square root of 2 over 2 is your sine value as well. To find the tangent value, tangent of theta is going to be y over x. When I substitute in the values for this example, I have negative square root of 2 over 2 divided by square root of 2, negative square root of 2 over 2. So we can multiply by the reciprocal. We have negative square root of 2 over 2, flip the second fraction, 2 over negative square root of 2. Here you're going to see that everything is eliminated, including the negative sign. So when we simplify our tangent value, or our tangent of theta answer, our answer is just 1. Please try to complete the on your own section by yourself. The answer key is posted on my website if you would like to check out the solutions for these two problems. There's a note right here that says using reference angles or quadrantal angles, you should now be able to find the trigonometric function values for all integer multiples of 30 degrees, which is pi over 6 radians, and 45 degrees, which is pi over 4 radians. These special values wrap around to produce 16 special points on the unit circle. Use what you know to complete the unit circle on the next page. So I'm going to start you off for the unit circle, and then that's actually where I'm going to end the video today because I want everyone to be able to solve the unit circle by yourself. So if you go to my note sheet on my website, you can find the answers to the unit circle. Obviously, I know you can do that, but it's important that you know how to do this by yourself, especially if you're planning on taking calculus next year. None of this is hard. It's extremely repetitive. You just need to make sure you know how to do it. So this is what the unit circle looks like, and there's key values within the unit circle. I'm going to start by talking about the key values in quadrant 1. And in quadrant 1, recall that you always have positive x and positive y values. So within each quadrant, you have special angles. I want you to find, not just me, but the unit circle in general, is finding the degree measure. That corresponds with the radian measure. So you should all know how to convert degrees to radians. You multiply by pi over 180. And then at each point, and when I say point, I'm talking about this point, you have your x and you have your y value, which coincidentally is your cosine and sine value without doing any other work. So within each point, or within each quadrant, you have 3 points. Each point has a degree, radian, an x and y, or more specifically, a cosine and sine value. All of the points on this unit circle are either 30, 60, 90 or 45, 45, 90 triangles. And then all of the quadrantal angles are angles that you already learned about last lesson. Quadrantal angles are multiples of 90. So think back to the last lesson. What is this point? Just give you a heads up on this one. This point is at 0, 1. And 90, if we convert that to radians, 90 converted to radians is pi over 2. If I was to ask you the cosine value of 90, cosine value of 90 is your x value, it's 0. If I was to ask you your sine value of 90, your sine value is 1. Okay, so besides quadrant 1, if we just label all of these here, quadrant 2. Quadrant 2 has negative x values, positive y values. Talking about quadrant 2, let's take a look at 150 degrees. So if I was to form a triangle with 150, I'm going to drop an angle right here. This forms my 90-degree angle. I also am going to indicate where my reference angle is, which is right there. This forms a 30-degree angle. What's left? 60 degrees. So I just formed a 30, 60, 90 triangle at 150. which you can all solve for, and that's the one I'm actually going to do. You can all solve for, which will give you your cosine and sine value. And you need to do this for the rest of them on the unit circle. So I'll come back to that, but while I'm talking, we're going to talk about quadrant 3, negative x, negative y. And lastly, quadrant 4, positive x value, negative y value. All right, let's do one of these. We're doing this one that I started. So we're doing 150 degrees. If I convert 150 to radians, multiply it by pi over 180, I know what this one is going to be. It's going to be 5 pi over 6 when you simplify that. All right, besides from your radian measure, we need to find where's this point. So what are your x and y values on that point? We're going to use a 30, 60, 90 triangle. I'm going to start with the fact that we know the hypotenuse is 1. Remember, we know that this value, this length, is always 1. So you're going to start with the hypotenuse. Hypotenuse is equal to the short leg times 2. And the short leg is across from the 30-degree angle. This short leg corresponds to the height on the y-axis. So I'm going to label the short leg as y. Substitute in the value of the hypotenuse, which is 1. The short leg, I'm using a variable y, times 2. Divide both sides by 2. Y is equal to 1/2. All right, so this value is 1/2. I'm going to label the last side, the long leg, as x. And recall that the long leg formula is equivalent to the short leg, which we just found, times the square root of 3. So the long leg is, we are representing the long leg with a variable x. This is equal to the short leg, which we just solved for, and that was 1/2, times the square root of 3. X is equal to the square root of 3 over 2. So now that we found the sides of our triangle, we're not quite done because we need to make sure we include the correct signs. So in quadrant 2, we have to make sure we include a negative x value. That tells me that my x value here is now going to be negative square root of 3 over 2. And quadrant 2 includes a positive y value, which is 1/2. So we just did the work. We know that 150 Sorry, just getting all that out of the way so we can talk about this. We know that 150 in degrees is equivalent to 5 pi over 6 in radians. And we also know that our sine value is our cosine value. Cosine value is negative square root of 3 over 2. And our sine value is 1/2. All right, cosine is x, sine is y. You can do this for every angle on the coordinate plane, and that's what I want you to do for the rest of this class. So fill in your unit circle. Please try not to just copy it down because it's not going to help you. Please make sure you actually try to figure out how to do these. Make sure you understand it. Check your answer against mine on my website. Again, it's imperative that you know how to complete the unit circle. Okay, and tomorrow we will finish this note sheet.